What I've put together here is a head-to-head compressor comparison chart. Trawled the internet for forever, and when I was doing the most recent patent, I had to look and see if there's anybody come up with anything similar, and from what we found out, there still is nothing quite similar. However, there's two companies that manufacture. There's a company called Danfoss that manufacture a compressor that works in the same space, and there's another one called Boyard with a compressor that works in the same space. But in saying that, they're just nowhere near the same efficiencies as what I've managed to get. What I've got is I've got the TDI R800 and the TDI R875 with the Boyard and the Danfoss. So what we've got here is it all rated at 12 volts. That's the current input of mine at 14 amps, the R875 at 16, the Boyard at 31 and the Danfoss at 32.5. You can see in the displacement there are other features through here, but there's the displacement, 6.7 of the standard compressor, 8 of my larger capacity one. This one here is roughly about 5.3, somewhere thereabouts, and this one's 5.8. Now what these guys also do is that to get that, the RPM that they spin the compressor at is 4,000. These guys at 3,700. I'm at 2,100 and 2,100 again. And so that's all fairly relevant because I believe this compressor here, and that was validated by a major electric car manufacturer, that Boyard seems to be the yardstick compressor that's used in all of the electric cars. Now, the E-drive, which is the distance that they can travel once the battery's been fully charged overnight, is extended incredibly if they just simply use this compressor in comparison to this compressor. So you can see that at 14 amps as opposed to 31, that there's an enormous difference there in the distance that the car will travel. And it seems like 200 miles is a figure that everyone that manufactures electric cars has to try and exceed. And by putting this compressor here into the situation where this compressor is, this car, if it travels 200 miles, this car will travel 280 miles just simply by replacing this compressor with this compressor. So I just thought I'd throw that in to show you what's going on. And this conclusion here is actually written from an independent engineer who works for the electric car manufacturers. So this is his words. The cooling capacity of the TDI R875 compressor is 20% more. The rated power watts to run the compressor is only 58% of the Boyard compressor, and the current to run the TDI compressor is only 54% of the Boyard. Now he was using this comparison, not this comparison, so just to let you see that. Now the other thing that I've gone and done here is that my standard compressor runs at 2100 RPM, and I've built a slightly larger compressor, it's 20% larger, which still runs at 2100 RPM. Now I did some sums, I haven't done a full test on this yet, but if I run this compressor here at 2100 and overspeed it to 2500, the output that I get is pretty extraordinary, which makes me think that maybe I don't need to build any larger compressors. I can gain the result that I need by simply increasing the RPM. Now if I increase the RPM of this one, the output goes up to somewhere around here, which is getting pretty seriously close to double the output of what the guys are currently using. So I don't know that it's needed, because any serious increase in capacity comes at an increase in current, which is actually to the detriment, even though considerably less than these guys. It's still more than probably what it needs to be when I see that we can get the increase in output, which is still half of where we're at over here. So I just popped that together to give you some idea of the importance of keeping the current down low.